Today for our Math Strategies video, we're going to be talking about line plots. So line plots are data displays that show the frequencies of the data as marks above a number line. And those frequencies tell us the number of, and that those marks are usually X's above the number line. So let's say, for example, we measured insects in inches, and we wrote down all of our data here in a list, okay? So instead of just looking at this list, we could use a line plot to organize our data, okay? So the line plot below shows the sizes of different insects, okay? So when we look here above the 1, there are 3 X's, okay? And that means that there were 3 insects that we measured that were 1 inch in length. And if I look over at my list here, I see I have 3 1s, okay? Now, if I look at the 1 1/2 mark on my number line, I see 3 X's again. And that means there were 3 insects that measured 1 1/2 in length, okay? So if I look over at my 2 on my number line, I don't have any X's there. And that means that none of our insects measured 2 inches, okay? So if I look all the way down toward the end of my number line at 3 1/2, I see the most common measurement that we found, which was 3 1/2, because there are 4 X's above 3 1/2, which means there are 4 insects that measured 3 1/2, okay? So sometimes if we're given a data, it helps to organize it as we're recording that line plot. So let's take a look at this set of data, and let's take a look at this number line and see if we can put some X's there to organize it a little bit. So as I look at this data set here, I see that there is a 5, and I'm going to go ahead and I'm going to take that 5, I'm going to put an X above the 5 on my number line. That means I only have 1 5 in my data set, okay? So I see I have a 1 5 1/2, so I'm going to put 1 X above that 5 1/2. I have 2 6's, so I'm going to put 2 X's above my 6's. And then I have 2 6 1/2's, so I'm going to put 2 X's above that on my number line. I have 2 7's, and I also have 2 7 1/2's, so I'm going to put 2 X's above 7 1/2. And the only number that is not showing up in my data is 8, and that's because I don't have any X's above that 8 in that data set, okay? So now let's take a look at another line plot and see if we can answer some questions based on this line plot. But before I dive in and start answering questions, I'm just going to kind of analyze and interpret this data first. The line plot below shows the distance students lived from the school in miles. Okay, so if I see 1 X above the 5, that means 1 student lives 5 miles from school. If I see 2 X's above 5 1/2, that means that there were 2 students that lived 5 1/2 miles from school, okay? And so forth. I can look here at 7 1/2 and realize no students lived 7 1/2 miles from school, okay? So after kind of looking at this data, now I can begin to answer some questions on it. So the first question is, how many more students lived 5 1/2 miles from school than 5 miles from school? Okay, so I know 5 1/2, there were 2 students, and 5 miles, there was 1 student. So 2 minus 1 is going to give me 1. So there was 1 more student that lived 5 1/2 than 5. The next question is, how many students live 6 or more miles from school? So I'm going to start at my 6, and I'm going to count my X's. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. So there's a total of 8 students that live 6 or more miles from school. So our last question is, what is the most common distance from school? This actually has 2 answers, okay, because I have 2 X's above 5 1/2, and I have 2 X's above 7 3/4. So those 2 distances are the most common distance from schools. So as you begin to interpret and create line plots, remember your knowledge of number lines, fraction equivalents, as well as addition and subtraction of fractions to help you.